In this video, we are going to work through how to compute a sum that is written in sigma notation. So we know we could actually write down all of the terms in this series and add them together to get the sum, but that's not going to be a very efficient method, especially when there are a lot of terms. So instead, we want to identify what type of a pattern we have. And we're going to do that by taking a look at the general formula. So the formula rule to the right-hand side of sigma is 1/3 to the k power. And there's two main types of sequences that we are studying, arithmetic and geometric. So we're trying to determine if this particular pattern is either arithmetic or geometric. And if you notice that this formula here is exponential, then that's one way to realize that it is going to generate a series of numbers which will be geometric. So this is definitely a geometric series. Now, if you didn't realize that by looking at the expression or the general formula on the right-hand side of sigma, then you could certainly actually write down a few of the first terms by plugging in k equals 1 to get the first term, and then k equals 2, and so on. So let me show that. My first term, a sub 1, is found by substituting in k equals 1, and 1/3 to the first power is just 1/3. So let's do that for the second term, and we will substitute in the next whole number, which would be 2. So 1/3 to the second power is 1/9. And I recommend doing it 3 times so that you get 3 terms, so that you can be really confident with the pattern here. 1/3 to the third power, remember you're just raising the numerator and the denominator to the third power, and that'll be 1/27. So now the question is, how do we go from 1/3 to 1/9 and to 1/27? And we are multiplying in this case. Hopefully you can see that you're multiplying by 1/3. 1/3 times 1/3 will give you 1/9. 1/9 times 1/3 will give you 1/27. So this is another way of coming to the realization that we have a geometric series, and this also tells me the value of r. The common ratio, the number that you're multiplying by, is 1/3. Now, even if you didn't write down the first few terms, you could still figure out that common ratio by looking at this expression, your general rule, and realizing that the base of this expression is 1/3. And the base will always be that common ratio. It's what you're multiplying by repetitively. So we know that r is equal to 1/3, and we have a geometric series. So our formula for a geometric series, the sum of n terms, is going to be a sub 1, the first term, times 1 minus r raised to the n power, all divided by 1 minus r. Now, if you're working on a problem like this in ALEKS, ALEKS writes this formula a little bit differently. They basically rewrite the a sub 1 in front and then multiply it by the fraction 1 minus r to the n power over 1 minus r. But these are equivalent formulas. It doesn't matter which one you use. This one happens to be my preferred one. So we need to figure out how many terms we are adding together. In this example, we are starting with k equals 1, and then we will substitute in 2, and then 3, and then 4, and on until we substitute in 9. So if we go from k equals 1 to 9, that is a total of 9 terms. So n is equal to 9. Remember, that's telling us the number of terms that we are adding together. So we're really going to be computing here the sum of the first 9 terms. So using our formula, s sub 9 will be equal to a sub 1, the first term. A sub 1 is found by plugging in 1, and we actually already did that over here. When you substitute in 1, you get 1/3. So the first term is 1/3 times 1 minus r, the common ratio, which is also 1/3, raised to the 9th power, since we're summing up 9 values, divided by 1 minus 1/3. So I highly recommend that you grab your graphing calculator and pause the video here and practice putting this in. A few reminders. If you are on a TI-84 calculator, then I highly recommend that you use the shortcut menu to get the vertical fraction notation. And that can be accessed by using the alpha button and F1. And F1 is the shortcut menu that is above the Y equals button on your calculator. If you are on a TI-83, then just be sure that you have parentheses around the denominator so that you're dividing by both the 1 and the minus 1/3. So once you have inputted this expression, you should get a decimal answer about 0.49997. And this is the approximate value of this summation. However, if you're working on ALEKS, ALEKS specifically asks for an exact answer written in fraction form. So typically, when we get a decimal on our calculator, we can use our calculator to convert that decimal to a fraction. And a reminder of how to do that, you are going to find your math button on your calculator and then choose the first option, which says frac, and that stands for fraction, which will attempt to convert a decimal to a fraction for you on the graphing calculator. But you'll notice when you try that for this particular decimal, the calculator will just return back to you the same decimal, meaning that this does not work for this particular problem. For this particular R value, the calculator is not going to be able to convert the decimal to a fraction. So I'd just like to show you how to do that by hand, using your calculator, of course, for some of the computation. We're just going to have to work with these fractions a little bit. So the first thing we're going to have to do is actually take the 1/3 and raise it to the 9th power using our calculator. So we have 1/3 times 1 minus. Now 1/3 to the 9th power is really equivalent to raising the numerator to the 9th power and then also raising the denominator to the 9th power. Well, 1 to the 9th power is just 1, so you can then use your calculator to compute 3 to the 9th power, because that's going to be a large value. Go ahead and be sure that you're trying it with me. That should be 19,683. So we'll have 1 minus 1 over 19,683. Now in the denominator, we have 1 minus 1/3. We can go ahead and simplify that to just be 2/3. Next, we need to actually go ahead and subtract these fractions here. 1 minus 1 over 19,683. So think about a common denominator. That's like 19,683 over itself. So that's equivalent to 1 minus 1 over 19,683. Therefore, that portion is going to simplify to just be 19,682 divided by 19,683. Now, rather than continuing to write this as a complex fraction, in other words, instead of writing divided by 2/3, why don't we go ahead and change that to multiplying by the reciprocal? That'll make this a little easier as well. So dividing by 2/3 is the same as multiplying by 3/2. And this works out pretty well because then we can see that these 3's are going to divide out. And I can even divide the 2 into the 19,682 using your calculator. So 2 divides into 19,682 9,841 times, which means right now I have a simplified fraction of 9841 over 19683. 9,841 divided by 19,683. And you could go ahead and try to simplify that, but it turns out you can't simplify that any further. And if you want to check that, that is indeed going to be equivalent to our decimal that we got earlier of about 0.49997. So when you are unable to use your calculator to convert your decimal into a fraction, you'll just have to do a few other steps dealing with the fractions so that you can get a simplified answer. And then this is going to be our answer down here that we would enter on ALEKS because this is an exact form. I hope that's helpful.